Hey folks, today we're going to walk through the first lesson in the plate tectonics module in High Adventure Science. So go to learn.concord.org and find this activity. What will Earth look like in 500 million years? I'll talk through lesson 1 for this video. Feel free to pause it as you need or fast forward. When you're done with your assignment, be sure to send me an email so I can get your score entered. If I click on the first lesson, I'll go back to the home page of this lesson. You'll see it says Earth's moving surface. And this page describes that we'll be using GPS data today to gather evidence that parts of the Earth are moving. The first page shows an image of the Earth, and this is an image of the Earth taken from space. You can see the outline of Africa, Saudi Arabia, and Antarctica. And the question is, how do you think Earth might look in 500 million years? And of course, they are referring to, in this question, the appearance of Earth itself, the land masses, the oceans, etc. Then explain your answer. Why do you think that? Feel free to pause if you need time to work on this. The next page talks about GPS stations. GPS stations, in addition to being used to track where you are in your phone or your car, are used to track the motion of different parts of the Earth. This image, this map, shows different GPS stations around the world. The green dots represent the location of the stations. The yellow lines represent the direction the station is moving. And the length of the line represents how fast the station is moving. So, for example, this station up here in northern Russia, the dot is located right there. That's where the station is, and this area is moving to the east at a relative speed that seems a little bit longer than some near Europe. If you look at Europe, you can see it appears they are moving to the northeast, some over here to the northwest. If you look at Minnesota, it looks like Minnesota is moving almost due west. Questions. Are all GPS stations on Earth moving the same direction? Yes or no? And what is your evidence? When citing evidence, be sure to use actual examples from the map. Page 3. Back in time. It says GPS data shows that Earth's surface is moving very slowly, but over a long period of time, you might be able to see changes in position. So, taking a look at Africa and South America. Where do you think Africa was located 10 million years ago, seeing its current position with the GPS stations and the direction of movement it's currently moving? Would it be 10 million years ago? Was it to the northeast, over here, to the southwest, over here, or the same location? And explain your answer by typing in there. Next, we're going to plot volcanoes and earthquakes. This is called Seismic Explorer, and it uses current earthquake data. I'm going to go ahead and replace snapshot. And what we have here is a map. I'll move it here. And this map, like I said, will show earthquake data. Now you see I accidentally zoomed into the map. If you do something to the map where it's not in the location where you would like, simply go over to the left, the box with a circle on it, click that, and it will take you to the original place that you should be. So on this map, we're going to plot volcano and earthquake data. I know the directions say that volcanoes are already plotted. It is not. So I'm going to click data type, I'm going to go ahead and put the continent and ocean names in there because might not remember them. And then the volcanic eruptions. So all those little triangles are volcanoes. There's a key up here to determine, close that. The key shows me how the last time the volcano erupted. So many white ones are active, orange ones are more recent, and so on. Next, I'm going to go ahead and I've already selected a data type for earthquakes, but I'm going to have to go ahead and press start to have earthquakes erupt or occur. This shows since 1980 all the way until today when I'm filming this. And the earthquakes also have a key to them. And the key to the earthquakes, the color indicates the depth of the earthquakes, and the size of the circle represents the magnitude of the earthquakes. So you can kind of look around there. Our questions today deal with question 7. Says take a snapshot and circle where you see lines of both volcanoes and earthquakes in the same place. So you're looking for lines of volcanoes and earthquakes. And what do you notice about the lines of volcanoes and earthquakes and where they seem to occur on Earth's surface? And what are your initial ideas about why earthquakes and volcanoes might happen in lines? One trick that I did, just for a brief, I'm going to restart. Aside, if you center the Pacific Ocean on your map and then press start, you will see maybe a better illustration of lines of volcanoes and earthquakes all along around the Pacific Ocean. Okay. Answer those questions and go to the next page. Next one is planet in motion. So we're going to take a look at another computer model called Tectonic Explorer. And this one will allow you to observe what happens when continents and oceans collide. So I'm going to go ahead and press the start button once I get started here. Now, this I can move around, look at different things. I'm going to take a look at this continent here. I do know what's going to happen. So when I press start, you'll see that is showing two areas moving apart. I'm going to stop it. I can see something occurring in here. What is that? If I look up to the key, it looks like a little bit of a rise in elevation, meaning there must be a mountain range forming underwater here. If it gets up to brown and so on and white, those are even taller mountains. I'm going to go ahead and move over here to take a look at, as these are moving toward each other, I see some mountains forming on the coast here. If I hit start. So what's happening is this is moving is toward it. Volcanoes, earthquakes, mountains are forming on the boundary of the continent. And then as the continent collides, you'll see more mountains forming on the continent that is colliding. So something's going on there. Questions. What changes to the planet's surface do you see as the model runs? Describe what happens when two pieces of surface are moving toward each other. And describe what happens when two pieces of surface are moving away from each other. So some descriptions there. The last page that you're going to be working with, questions, is taking a look at Earth in the past. This shows maps of the Earth as if we go back in time. This is present day. And as you click, you can see the number of years going back further and further. And you can see what it looked like in the past. All the way back to what's called the late Cambrian, 514 million years ago. Questions. Start with the late Jurassic map, which is 152 million years ago, and move forward in time. Describe how South America and Africa moved compared to each other, and what happened to the South Atlantic Ocean over that same period of time. Okay, so I'm going to start at 152 million years ago. Here's the continent that is Africa. Here's South America. You can see where they are, and then as you move forward in time, you're taking a look at what happens to those continents as well as to the South Atlantic. There's a South Atlantic all the way into present day. Answer those questions and you are done with activity 1. Remember to email me when you complete it so I can enter the score into Schoology. And let me know if you have any questions.